In this problem, we have a board that is being supported at point A by, as you can see, it's a roller. So this is incorrect. And at point B, a hinge. It's subjected to a 400 Newton force, and we need to determine the support reactions at point A and at point B. The coordinate system, again, is given. So again, the first thing we do is to sketch out the free body diagram. We have the 400 Newton force right here. And then we need to draw the unknown support reactions at point A and point B based on what type of support it is. Point A, we have a roller, and it can only prevent the member from going down. Therefore, it only provides one force reaction, that is vertical up. At point B, the hinge actually prevents all kinds of motion except for rotation about the y-axis. Therefore, it provides all support reactions except for a moment about the y-axis. So we have force in all directions, bx, by, and bz, and moment about two direction. So we have moment about x-axis and the moment about z-axis. So as you can see, at this point we have completed the free body diagram, and we have overall 6 unknowns. We have 1 here and 5 here. So we have one 3-dimensional rigid body free body diagram, and we can solve for maximum of 6 scalar unknowns, and that's exactly what we have. So now we're ready to write our equilibrium equations. Again, we do scalar approach. Resultant force along the x direction equals to bx, and that is 0. Resultant force along the y direction equals to by, and that is also 0. Resultant force along the z direction equals to az plus bz, and we have the 400 Newton force vertical down, and that equals to 0. Resultant moment about the x-axis. We have an unknown moment, and we need to count that first, and then we try to determine the total moment caused by the forces about the x-axis. So this force az here is causing clockwise rotational effect about the x-axis, so minus az multiplied by the moment arm, which is 2 meters. And then the 400 Newton force is also causing clockwise rotational effect, so minus 400 with a moment arm of 2 meters, and that equals to 0. The other 3 forces, bx, by, and bz, because they all intersect with the origin, therefore they do not create moment about any axis. And the last one, mz, it is a moment about the z-axis. So that's all for the mx equation. And then moving on to the resultant moment about the y-axis. Again, the 3 forces bx, by, bz don't have moment about the y-axis. mx and z, they are not about the y-axis. So az will have a moment that is clockwise, therefore minus az times the moment arm is this moment arm right here, which is also 2 meters. And then the 400 Newton force is creating counterclockwise rotation, so plus 400 with the moment arm of also 2 meters, and that equals to 0. And lastly, resultant moment along about the z-axis. Again, bx, by, bz don't have moment about any of the 3 axes. Mx is about x-axis, so we have mz, that is the moment about the z-axis. Az and the 400 Newton force, they are both parallel to the z-axis, so they do not create any moment about the z-axis. So this equals to 0. So now we have 6 equations from there we can solve for our 6 unknowns. We already know that bx and by are both 0. We already know that mz is also 0 from the last equation. So from this equation, we can solve for az, and az simply equals to 400 Newton. And then substitute az into this equation, we can solve for mx, and mx equals to 1600 Newton meter, or 1.6 kilonewton meter. And then because we know that az equals to 400 Newton, substitute into this equation, we can solve for bz, which is also 0. So that's the solution to this problem.